Hello friends, in the previous video we have looked at four methods to handle the input token limit by the large language models for doing the summarization tasks. Okay, in this video we will implement those four methods. Okay, so we are going to use the Google Cloud platform and the LLM models developed by Google, and then we need a couple of other libraries like PyPDF2. We are going to process a PDF document, and then these two additional libraries, rate limit and backoff. Okay, so install those libraries, and then yeah, so import Vertex AI. So when we install the Google Cloud AI platform, that will install the Vertex AI, which is the machine learning platform from Google. Okay, then register an account for Google Cloud. There you can create a project and get your project ID. So I have already done that. Now it's a very standard process. You can create your Google Cloud account from Gmail also. And then you need to log in using the by running the Google Cloud CLI commands. Okay. If you are facing any difficulty, please let me know. But I don't want to make this video longer by including the account registration and the login process, etc. Okay, but just get your project ID and paste it here and run this part of the code. And then here we have some standard Python libraries, and then from Google here we have exception, but more importantly we have this text generation model. Okay, all right, and then so from text generation model we are using this text bison at 001 model for summarizing the text. Basically it's a text generation model. We can use it for question answering, text generation, the summarizations, etc. All right, and then we are going to download a PDF documents from Google, which is about this MLOps. Okay, so we are creating a folder called data using this pathlib library. We are just creating this folder if it does not exist, and then this is our PDF URL. Okay, and here we this is the PDF file. So basically we are saying it should be saved in this data folder with this name. Okay, that's what we are doing it here, and then using the URL lib we are downloading the PDF. So I'll quickly show you how the PDF looks like. Right, so this is the 37 page PDF document we just downloaded. Okay, so the first page, it simply has a title and the author signed some image, practitioner's guide to MLOps. Okay, and the second page, the table of content, and from third page the actual content starts. So as you can see, it's a very densely packed text. It has some diagrams and over 37 pages of text related to the MLOps. Okay, all right, let's go back, and okay, so we have downloaded our PDF file, and then we use this PyPDF2 library to read the content of the file in the form of text. Okay, so we simply supply our PDF file path, and then we get the pages. So that we get the content of the PDF file page by page. Okay, so if we, so here we are just looking at the first 3 pages. So we are going over the first 3 pages and extracting the content. Okay, so page 0, as we saw, it has the book title, Practitioner Guide to MLOps, so and so forth, and then the author's name. Obviously the image is ignored, and then on page 1 we have the table of content. Okay, and page 2, the executive summary. This is where this bulk of the text start. Okay, quite densely packed, rich information. So those are the first 3 pages I have looked at. And the text is extracted quite well from this PyPDF2 library. Okay, all right, now maybe in the next video I'll explain you that we don't need to work with only one document. We can work with a folder where we can have multiple PDFs, text documents, maybe HTML files, etc. Okay, so the first method we saw, stuffing method. It's simply inputting the text document as it is. If the number of tokens in the document is within the allowed limit, then the process works. If it's more than the number of tokens allowed, then the process fails. Then what we do is we simply truncate the text. We allow only up to the number of tokens allowed. So that way we can create the summary. Okay. So again, we are just using the same PyPDF to PDF reader. So we got the pages here. And then here we are going over the pages one by one, and we are creating this variable called concatenated text, which going to contain the text from all 37 pages. Okay. So here, as you can see, we looped over all the pages, and then for each page we have extracted the text, and the text we have concatenated to this variable. Okay, so our total text, which is this concatenated text from 37 pages, it has some 64,000 number of characters. Okay, so if we roughly say, let's say 5 or maybe 6 characters is one token, so which means we have over 10,000 tokens in this document. Okay, all right. Now here we are just printing the number of characters in the first 5 pages, right? So for example, the first page, it contains only the title and the author names, so only 187 characters. And the second page, the table of content. But after that, you can see each page is full of text. So each page roughly has about let's say 2,500 to 3,000 tokens, characters. All right. So this is how the concatenated text looks like. So starting with page number 1, practitioner guide to ML ops, so on and so forth. Okay. So the total some 65,000 characters. Now, what we do is, so let's create a prompt template so that we can use this template with this text as the variable. So we can insert a different text when calling the function. Okay, summarization function. Okay, so the prompt is simply write a concise summary of the following text delimited by triple back quotes. So we are going to insert our text here. So those 37 pages of the text we are going to insert here. And then we are saying return your response in bullet points, which covers the key points of the text. Okay. And then we have this bullet point summary. Now, so here we have the prompt template. I mean, we are just, it's a Python a string formatting thing, right? So we are formatting the text and we are replacing this part text with our concatenated text. Okay. So the concatenated text has the 37 pages content. And then here we are calling the model. So we are calling the generation model with the prompt, and this is the number of output tokens, the maximum number of allowed output token. Okay, that's usually 1024. Okay, so we are going to get the summary in 1024 tokens if everything worked well. But as you can see, we got an error. The error message is not so informative, but it simply says invalid argument. Now, if I go here, so it says this error is generated when we call the model. It did not explicitly state that the token limit exceeded the allowed, but that's what the error is. Okay, so here we have a document which is larger than the number of tokens allowed. So as you know, in stuffing method, we simply truncate the document, right? So this LLM model, it allows up to 8,000 tokens. But here, this is for demo purpose. So what we are doing is, we are taking only the first 5,000 characters from the text. Okay, so instead of passing the whole concatenated text, which contains the 37 pages, we are just simply taking the first 5,000 characters. So which loosely translate to maybe, let's say, 1,000 words or tokens, right? So if we go back here, so these are the number of characters, right? So which means page 1, 2, 3 and 4. So we are going to summarize the first 3 pages and partially the 4th page. Okay, so the total number of characters, 5,000, right? Now we don't need to do that. I mean, we can we can find out the maximum tokens allowed, which, as I mentioned, is around 8,000. So we can summarize even longer text than simply these 5,000 characters, but this is just for demo purpose, right? Okay, so here we have the prompt, new prompt, which is the shorter text, and then we are calling the model. So as you can see, it has created the summary in bullet points as per our prompt. Okay, and if you look at the maximum number of tokens, this would be less than 1024. Okay, so here we have 1, 2, 3, 4 bullet points. So MLOps is a set of standardized process and technology, so on and so forth, so on and so forth. Okay, all right, that looks good. Now, the advantages and disadvantages of all these methods we have discussed in the previous video, so please refer to it. Now, these API calls, they have certain limits to prevent from misuse or bots, or even by accident we are calling the APIs in a loop, right? So that will increase the bill. So as a safety measure, all these models have some rate limits. Okay, so here what we are doing is, we are simply using this rate limit and backup functions from Python just to handle how many maximum calls we can make per minute. Now, if the resources are busy, or if the process could not be executed, now how long do we want to wait, or what is the maximum amount of time we want to try this process? Okay, now don't worry too much about this part of the code. We can use this as it is. If needed, we can change these numbers. So here what we are saying is, we are allowing maximum 20 calls per minute. Okay, and then we are allowing this process to run up to a maximum of 5 minutes. Okay, so this one is just printing stuff, and here we are defining the maximum time and how many calls are the rate limit. Okay, so the maximum time is 5 limits, and then the rate limit is 20 calls per minute. And then when we call these models, we pass these as arguments. Okay, so again, don't worry too much. If needed, you can change these 3 numbers, but we can use this code as it is. Okay, all right. Then the second method, map reduce, right? So here we split our document into smaller chunks, and each chunk will be within the maximum allowed tokens, and then we process each chunk separately. So we get the summary for each chunk, and then finally we will come, that's the map step. And in the reduce step, we will combine the summaries from all the chunks and then create a final bullet point based summary. Okay, so that's the map reduce. That's how the map reduce works. So the initial prompt, which is for map. So what here we are saying, write a concise summary of the following text delimited by triple back quotes. So here we have the text, and then we have the concise summary. So that's our initial prompt template. And then final prompt, So this text is going to be a chunk by chunk, whereas this text is going to be the concatenated summary of all the chunks. So this time we are saying, again, write a concise summary of the text and return your response in bullet points. Okay. So here we have two prompt templates, one for initial, one for final. So the initial one we will use for during the map operation. The final prompt will use during the reduce operation. Okay. Again, the same stuff. We are reading the PDF. So here we have the initial summary and empty list we initialized. Now here we are taking each page as one chunk. Okay. Now that's one way of doing. The other way of doing is we extract all the text. Again, let's say it has 10,000 tokens. Now let's say our model has a token limit of 2000. Now let's say the text we extracted is from 10 PDF pages. Okay. Now here what we are doing is we are taking each page irrespective of the number of characters or the tokens as one chunk. The other way to do that is we can take all the 10,000 tokens and we divide into simply 5 chunks. Each chunk will have 2,000 tokens. Okay. It's up to us whichever method we choose. But because we are using this PyPDF library, which extract the text page by page, here we are taking each page as a chunk, but that not necessarily be the best method. Okay. So what we are doing is we are looping over all the pages one by one. Now we don't need to have stopped at 5 pages. We can run it for all 37 pages. But again, this is for the demo purpose. So just to reduce the cost, we are processing only the first 5 pages. Now, by the way, when you create your Google Cloud account, you will get $300 worth of credit. So even if you are processing all the 37 pages, you don't get charged more than a couple of dollars. Okay. So it should be fine even if you run for all 37 pages. All right. So we get the text. We are extracting the text for that page. And then we are creating the prompt using this initial prompt template, right? So we are creating the prompt using the initial prompt template. So we are supplying the content of each page, page by page. So here we have the text, and then we are calling our model with this limit and backoff, rate limit and backoff, right? Okay. So here we have the prompt, and then our output should contain no more than 1024 tokens. All right. So we get the summary. Now this is the summary for that page. And then we are collecting the summary for all the pages. So here we are appending to this list initial summary, this summary from all pages. Okay. So here we have processed the 5 pages one by one, and we have appended the summary of all 5 pages into a list. So if you look at the length of the initial summary, it's this 5. And let's say the initial summary of the second page. You remember the second page is the one which has the content. So for example, if you look, let's say page 0. Okay, I have overwritten somewhere here, but what I can do is I can rerun this again. The context. Yeah, I just rerun the code in summary model with context key. Okay, all right. Let me do this thing because when I ran the method 3 and 4, some of the variables are overwritten. So what we do is let's do this. That's the thing. And then let's run this. It should work. Yep. So it is processing. And then let's do this. Okay. All right. So the summary of first page, as you can see, even though we are allowed up to 1000 tokens, it's just this one line. The reason for that is Control F. So if you look at our document, our first page, it simply contain the document title and then the author's name. That's all, right? page 2 contains the table of content, but from page 3 we have the executive summary and then the actual content of the PDF. So that's why the initial page summary is simply a framework for continuous delivery and automation of machine learning. And for page 2 or which is the content, we don't have much, but from page 2 you can see we have a nice summary. All right, and then here we are just so we have this initial summary as a list, and we are making it to one long paragraph or text. Okay, that's the map phase. Okay, now if you look at the number of characters, that's 1700. Okay, so which is the summary of the first 5 pages. So this is the summary of page 1, then summary of page 2, this is the summary of page 3, page 4, and then page 5. Okay, so because we have processed only 5 pages. Now what we do is we take the summary of all these pages and then we do the reduce step. Okay, so here we are creating a function called reduce. We are simply supplying the summary from these 5 pages and then the prompt template. Okay, so yeah, so here we are creating the prompt from the prompt template using this concatenated summary, and then finally calling the model with the prompt and then returning the summary. So we are doing the reduce phase, and by simply supplying the initial summary of the first 5 pages and also the final prompt template. And just to, so here we define the final prompt template where we are saying, hey, take all this text and summarize this in the form of bullet points. Okay, all right. So then here we have the bullet point summary of the first 5 pages. Okay, so to quickly summarize, in the map reduce, during the map function, we have divided our 37 page document into 37 chunks. Each chunk corresponds to a page. Then we created summary per page, and we have collected the summaries from all the pages. We have created a bigger summary by concatenating it, and then during the reduce phase, we have provided the summary from 37 pages to create our final bullet point summary. Okay, that's the reduce phase. All right, and the disadvantages with this method is here we have treated each page separately. For example, when we are processing the second page, it doesn't know what's in the first page, right? But often these pages are not disjoint from one another, right? Page 2 is a continuation of page 1. So we miss the context there. So that's why in the next method, we are going to do map reduce with overlap chunks. Okay. So in this method, instead of processing one chunk at a time, we simply process a couple of chunks at a time. Okay. So for example, page chunk 1 and chunk 2, we process, and then chunk 2 and 3, then chunk 3 and 4. This way, we are preserving the context or the continuity between different chunks. Okay. All right. So what we do is, this is just the standard, the PDF thing. We are extracting the text. And then, okay, here we are defining the chunk size to be 2. Now this don't need to be 2. We can have 3 as well, but 3 will be too much because the same document or the same page we will be processing 3 times, right? As part of the 3 different chunk groups. Okay. So we get the pages, and again, to reduce the cost, we are processing only the first 5 pages. So we have the initial summary. Now this time, the only difference is this part. So in the previous code or the previous method, we are processing one chunk at a time, right? Whereas here we have defined this chunk size so that here we are saying pages to merge. So when we run this for the first time, we will be taking the text from page 192 or chunk 192, concatenating that text, and then creating the summary for page 192 together. And then we increment the loop. This time we process page 2 and 3. Remember, we already processed page 2 in first iteration. In second iteration, we are processing page 2 along with page 3 for that continuity. Okay, so that's what we are doing here. So using the chunk size, right? So we are extracting 2 pages at a time, and we are creating the prompt out of those 2 pages, and this is where we concatenated the text from 2 pages, and then we have created the summary for those 2 pages or chunks together. And then we are collecting all the summaries in this initial summary variable. Okay, so that's our map phase. Now obviously if we do not have more pages, so when we reach the last page, we don't have another page, right? So that's where we stop the process. And then again, we have processed only 5 pages instead of 37 pages. But if you look at the summary, so this one is the summary of pages 1 and 2 together. Now compare this with when we process page 1 alone. So when we process page 1 alone, this is what we got, right? In the standard map reduce, where we processed each page separately without any continuity. This is the summary from page 2. Whereas here in this overlapping chunks method, we have processed page 1 and 2 together. So as you can see here, we have a much larger summary. And then for page 2 also, because we have processed 2 and 3 together, here we have again a much larger summary. Most of the summary coming from page 3, because page 2 is the table of content, right? And then during the reduce phase, we simply concatenate the summaries from these 5 function calls, and then we supply we use the final prompt template to call the reduce method. Okay, then here we have the bullet point summary of the first 5 pages. So compared to method 1, hopefully in this method 2, when we have the summary created, it has the continuity between the chunks or the pages. Okay, so this method is great, but as you can see, we have processed some documents multiple times. Well, each document at least 2 times, because we have defined the chunk size as 2, right? So this will blow up the cost, make the process slower, etc. Right? So those are the disadvantages of this method. Even though the summary we create, the quality will be excellent, because we have not missed the continuity between the pages. So the final and fourth method, it's the map reduce with a rolling summary. Okay. So in this method, or it is also called refine method. Now, instead of processing the multiple chunks by combining them, what we do is, let's say we process chunk 1, we get the summary. And then when we process chunk 2, instead of appending it with chunk 1, we take only the summary of chunk 1. Okay, so this way we are reducing a lot of text. And for the second function call, we are making it easier. So instead of supplying the raw document or the raw chunk as it is, we are simply supplying only the summary of the previous chunk. Okay, so while retaining the continuity and the context between the pages, we are reducing the amount of text to be processed, and we are also removing the duplication in this method. Okay, all right. So again, we have an initial prompt which says take the following context delimited by triple quotes. It's the same one. So here it will take the context. Now this is going to be the summary of the previous chunk, and then this is going to be the raw text of the current chunk. Okay, all right. The same stuff. So here we are processing the pages one by one. We are not processing the chunks together, but what we are doing is, when creating the prompt, we are supplying two variables. One, the summary from the previous chunk, and the current chunk. Okay, so if it's the first document which will not have a previous document, so here we are saying the context is empty. But from second page onwards, we are supplying the previous page summary which has already been processed or created, and then the current page text. Okay, so that's what we are creating the prompt out of, right? So again, going back to our prompt template, so the context will be, it's the summary of the previous chunk, and the text is the current chunk. All right, so we again call the model, the standard way of calling the method, and then for each chunk we are creating the summary, and then for the initial summary we are simply appending it. Okay, so here we have processed the 5 documents, and then we are calling the reduce function. We have already defined the template for the reduce function, and we have the initial summary. So this is our final bullet point summary. Okay, so this method is great because it overcomes the limitations of third method, where some chunks have been processed multiple times. Okay, but one disadvantages with this method is it's not fully parallelizable, or parallelizing it becomes a little harder. The reason is when we want to process a chunk, by that time we need to have the summary of the previous chunk, right? So that we can use that as a context when processing the current chunk. Yeah, that's the fourth method. So it's map reduce with rolling summary. This is also called this refine method. Some of these methods are implemented in long chain as well, so that we don't have to take care of, we don't have to do the loops, check if it is the first document or it is the document after that. We don't have to do again all these things, right? For example, we don't need to define the number of chunks, etc. So long chain, it has the pipelines for doing all this stuff. So in the next video, we will see how to implement it using long chain. That's all for this video. Thank you very much.